In this lesson, we're going to talk about how to evaluate higher roots. So let's start out by looking at the radical again. We know that the radical symbol means square root. And what about third roots and fourth roots and fifth roots, etc.? Well, it's like this. If 2 to the third power equals 8, then we can turn that statement around and write it like this. The third root of 8 equals 2. Notice that the radical symbol now has a little number in the crook of it, which tells me what power it took to change 2 into this number. Now, this number is called the index, and it goes in the crook of your radical. If we don't have a number there, we assume that it's a square root, or we assume that we're talking about second power. But with the number there, it tells us exactly what power of our base it takes to make this radicand. So here's another example. 3 to the fifth power equals 243. Now we can turn this around and we can write the fifth root of 243 equals 3. So notice that I've got the little 5 index in the crook of the radical. And so 3 to the fifth equals 243 can be restated as the fifth root of 243 equals 3. We're just turning it around. Here's one more. 2 to the fourth equals 16. So we should be able to say the fourth root of 16 equals 2. Okay? Now let's talk about roots of negative numbers. We said earlier that the square root of negative 9 is not a real number, but we can talk about the cube root of negative numbers because there really is a number that if I raise it to the third power I get negative 8. Negative 2 times negative 2 times negative 2 gives us negative 8. So it's valid to talk about the cube roots of negative numbers, but not the square roots of negative numbers. We can find odd roots, like third root, fifth root, so forth, of negatives, but we can't find even roots of negatives, like square root, fourth root, sixth root. So we're going to practice on a few of them here. The fourth root of negative 81. Now, because this is an even root, this number is not real. There's not a number that when you raise it to an even power, you get a negative result. So that's not real. However, the fifth root of negative 32 is negative 2, because negative 2, if we raise it to the fifth power, would make a negative 32. Okay, here's the third root of negative 125. Now the third root is an odd root, so I can have a number that when I raise it to the third power it's still negative, and this one will be negative 5. And here's one more. The sixth root of negative 64. Because this is an even root, this is not going to be real. So again, odd roots of negative numbers are negative. Even roots of negative numbers are not real. Now, it's important that you simplify under the radical before you start to evaluate the root. And let's just look at a few examples. We're going to simplify the third root of negative 2 to the third power. As long as it's an odd root, then, or in an odd power here, negative 2 to the third is going to be a negative result. And we know that the odd root of a negative comes out negative. But here is the fourth root of negative 2 to the fourth power. Negative 2 to the fourth is going to make a positive number. So what we're actually going to have here is the fourth root of 16. Even though this started out negative, when you raise it to the fourth power, now it's positive, and the fourth root of 16 is positive 2. Alright, here is an odd root and an odd power. So the fifth root of negative 3 to the fifth is going to be a negative number. and the odd root of a negative number comes out negative. So do you notice the pattern with the negative 3, still negative 3, but on the even root, we got a positive number out here. On the odd root, the negative base stayed negative. Okay, here's an even root of an even power. So this even power is going to make a positive result, and then the 8th root of positive 1 is 1. So notice that for negative bases, the odd powers and roots give a negative answer, but the even powers and roots give a positive answer. And just watch out for that when you're doing your homework, and that's all there is to that.